Okay, guys, we are going to go back and review the law of sines and the law of cosines here over the next week or two. The law of sines is obviously the easier one to do. If you remember from last year, I taught you both of these laws last year. Hopefully you remember them. Maybe some will, some won't. Okay, so the law of sines will work for any triangle at all, whether it's a right triangle or not, although I would never use it on a right triangle. But if you have a triangle that's not a right triangle, it certainly works out and gives you a way to solve it. Okay, so we have these ratios, okay, that all have to be equal to each other in any triangle at all. Okay, so if we take the sine of angle A and put it over top of the length of the side opposite it, so that'd be sine of angle A over little a, and the sine of angle B over the length of the side that's opposite angle B, so the sine of angle B over little b, and then the sine of angle C over the length of the side opposite it, little c, sine of angle C over little c. These three ratios have to be the same in any triangle at all. Okay, now, the law of sines can only be used in certain situations. We can't use it on any triangle at all. It depends on what information we're given about that triangle. Okay, so when can the law of sines be applied? Okay, number one. Okay, anytime we know two angles and a side. So it could be angle side angle where we know the included side between the two angles that we have, or it could be angle angle side where the side is a non-included side between the two angles we have. Okay, so if we have two angles and any side length, okay, it doesn't matter what, which way those guys are sort of put together, anytime we have two angles and one side length, we can use the law of sines. Now, we can use the law of sines when we have two sides and a non-included angle. So for instance, like this guy, okay, we have this side, and we have a non-included angle. Okay, if it was the included angle, we can't use the law of sines. We'd have to use the law of cosines. Okay, so it has to be SSA. It has to be two sides and a non-included angle. Now, this is where we run into problems. Okay, with this situation. Okay, this is called the ambiguous case of the law of sines. Okay, number one, okay, we could just have one possible case, one possible triangle that we're solving for. But it also could be the case that there are two different triangles, okay, that would satisfy, okay, this SSA situation. We could always also end up with no triangle. Okay, so that's called the ambiguous case. So we're not going to get into that today. So primarily we're going to be worried about two angles and any side whatsoever. Okay, and this is something we'll get into later on in the week. It's can be challenging, to say the least. Okay, so let's see. All right, so first guy. Okay, we have two angles and a non-included side, so this works out. Okay, we can definitely apply the law of sines. Okay, so let's see. First thing I'm going to do is set up, okay, my three ratios. Now, notice right off the bat that I can easily figure out the measure of angle H using the triangle sum theorem. So if I go 180 minus the 40, and then minus the 93, okay, I'm going to get the measure of angle H. Okay, so let's see, 180 minus 93 would give me 87, and 87 minus 40 would give me 37 degrees. And then obviously if you're worried about whether or not you have that correctly, just use your trusty old, okay, Walmart special. Okay, go 180 minus 93 minus 40, and obviously that guy, I have 47 here. Let me try that again. I got to make sure that's right. Okay, 180 minus 93 minus 40. I am getting 47 degrees, not 37 degrees. Okay, I'm glad that we checked that. I must have done some mental math incorrectly. Okay, so let's see. My three ratios. Okay, so if I go the sine of an angle, okay, so if I start with, say, angle F, I go the sine of angle F over the length of the side opposite it, so that'd be 10. So I have the sine of angle F, which is 40 pesos, over the length of the side opposite, which is 10. That has to equal the sine of angle G. So the sine of 93 pesos over the length of the side opposite that, which is FH. I don't know that. That's one of the things we have to solve for. And I go the sine of angle H, which is 47 degrees. Sine of 47 degrees over the length of the side opposite that, which is FG, which we're going to have to solve for. Okay, so I have these three ratios, and this guy is the important one, the first one. Okay, this is the cornerstone. And the reason this guy is so important is I know what the numerator is, and I know what the denominator is. Okay, but notice in this ratio I have an unknown in the denominator, and in this ratio I have an unknown in that denominator. So I use this guy, where I know both the numerator and denominator, to solve for that unknown and that unknown. It doesn't matter which order you do them in. So I'm going to go after FH first. So if I set this ratio equal to that ratio, I have a proportion. Okay, so we take that, first thing we're going to do. Okay, so I say the sine of 40 pesos over 10 is equal to the sine of 93 pesos over my FH. And then we just take the cross products like we would to solve any proportion. Okay, so I'm going to have FH times the sine of 40 pesos equals 10 times the sine of 93 pesos, and then divide both sides by the sine of 40. So FH equals 10 times the sine of 93 pesos divided by the sine of 40 pesos. All right, now I'm going to punch this entire thing into a calculator, okay, at once, and then just hit enter. So I want to make sure that I separate the numerator and the denominator, okay, using parentheses. And then obviously your calculator will automatically put that first parenthesis before the 93 pesos, so I need a second parenthesis, and it'll do the same thing before the 40 pesos, so I'll need a second one. Okay, so if I punch that entire thing in, we should be in good shape. Okay, so I say parenthesis, 10 times the sine, and the parenthesis comes up, put my 93 and then two parentheses, divided by a parenthesis, and then it would be sine, parenthesis comes up, I put the 40 in, and two parentheses, and hit enter. And it comes out to be approximately, when it's rounded off the nearest hundredth, I am getting 15.54. So FH is approximately 15.54. Okay, we do not have a unit of measurement, so I don't need one in my answer. Okay, so now we have to find FG. So now I'm going to go back to my cornerstone, use that guy, set it equal to this ratio, and then same process, solve the proportion. Okay, so the second part of this, I'm going to have the sine of 40 pesos over 10 equals the sine of 47 pesos over FG. And again, we have a proportion, so take the cross products. So FG times the sine of 40 pesos equals 10 times the sine of 47 pesos. And then divide both sides by the sine of 40. So my FG ends up being 10 times the sine of 47 pesos, all divided by the sine of 40 pesos. And again, I'm gonna punch the entire thing in my calculator. So I want those parentheses. Okay, calculator automatically generates that first parenthesis for the 47, so I need the second one. Does the same thing down here for 40 degrees, so I need the second one. And so we will punch that entire thing into our calculator. So we go parenthesis, 10 times the sine, parenthesis comes up, 47, two parentheses, divided by parenthesis, sine, parenthesis comes up, so 40, double parentheses, and hit enter. And I am getting, when I round off to the nearest hundredth, 11.38. And so this guy is 11.38. Okay, now, if I had a little bit more room, we might go back and check it. Remember, you can take these numbers, substitute it back up in here, and they will give you very, very close approximations. They should all work out. So we're in good shape. Okay, next one. We've got an angle, side angle. So unlike the last one where we had angle, angle, side, okay, this guy is angle, side, angle. But anytime we have two angles and any side, we can use the law of sines. Okay, so first thing I'll do, since I have two angle measures, first thing I will do is go use the triangle sum theorem to find the missing angle. So 180 minus the 58 minus the 62. It looks to me like we're going to get 60 pesos, but I'll go check it with my trusty Walmart special just to make sure. Lord knows I made a mistake on the last one. I don't want to make a mistake on this guy. Okay, we are getting 60 pesos, which I expected us to get. Okay, so let's see. If we go the sine of angle A, let me move this down. The sine of angle A, which is 58 degrees, over the length of the side opposite angle A, which is BC. That has to equal the sine of angle B, which is the sine of 60, over the length of the side opposite angle B, which is 23. And that has to equal the sine of angle C, which is 62 degrees, over the length of the side opposite, which is AB. Okay, so we take a look at those three ratios. Notice the guy in the middle is my cornerstone because it's the only one out of the three ratios where I know the numerator and know the denominator. Okay, so I'm going to set that guy equal to this guy and solve for BC. So that'll be the first thing I'll do. So I'll say the sine of 60 pesos over 23 is equal to the sine of 58 pesos over BC. And then I take the cross products. Okay, so I get BC times the sine of 60 pesos equals 23 times the sine of 58 pesos, and then divide by the sine of 60. So BC equals 23 times the sine of 58 pesos divided by the sine of 60 pesos. And again, I'm going to punch it into my calculator. So we add in our parentheses to make sure that we get the right answer, just like we did in the last problem. Okay, so I'm going to go parenthesis 23 times the sine, and parenthesis comes up, 58, double parenthesis, divided by parenthesis, sine, parenthesis comes up, 60, double parenthesis, and hit enter. And I'm getting approximately 22.52 when I'm rounding off to the nearest hundredth. So that is my BC. So my 22.52. And again, we do not have any units of measurement, so you don't need one in your answer. Okay, so now I have to find AB up here in this ratio. Okay, so again, I know everything in this ratio. That's my cornerstone. So if I set that ratio equal to this ratio, I can solve for AB. So let's see. In our second one, we get the sine of 60 pesos over 23 equals the sine of 62 pesos over AB. And we take our cross products. So I get AB times the sine of 60 pesos equals 23 times the sine of 62 pesos. And then we divide by the sine of 60. So AB is 23 times the sine of 62 pesos divided by the sine of 60 pesos. And again, put your grouping symbols in there, okay, because we're just going to, again, as always, just punch it right into our Walmart special and let it do its thing. So we go parenthesis, 23 times the sine, parenthesis comes up, 62, so it's double parenthesis, divided by parenthesis, sine, parenthesis comes up, 60, double parenthesis, and hit equal. And I am getting 23.45 when it's rounded off to the nearest hundredth. Okay, so this guy should be 23.45. Okay, let's see. Does that make sense? Well, notice your largest angle is angle C, and the longest side is opposite that. That's good. The smallest angle is angle A, and your shortest side is opposite that. That's good. And notice that all three angles are really close to 60 degrees, so this is really close to being an equilateral triangle. And notice that the three sides are really close to being the exact same length. So we should be in good shape there. If you're worried about it, just take these numbers, go back up and check to make sure that you're getting the exact same ratios. Okay, this will be the first video of the week. There will be more to come. You guys, if you need to get in touch with me, either leave me a message on Google Classroom or send me an email. Stay safe out there.